All right, well, we are on to Unit 1, Lesson 13, and this is a pretty big lesson. It's actually technically 2 full pages front and back, so 4 pages total. I'm only going to have you do this first page on your own, and then we'll work through some of the other stuff together, because that's a lot. Okay, so we're going to start off by just looking at number 1 here real quick. It says, so think different types of problems for each exercise, okay, and write an equation for the problem and then solve it. So we have here a math mountain or a number bond, whichever you want to use is fine. So we have our total up here, or our whole, and we have one of our parts, okay, and our other part is just labeled as A, and so we're trying to find what A is, okay. Up here we see that A plus 278 equals 747, and so there's one of our parts, right? So I'm just going to label it as a P, and here's our whole, label that W, and here's our other part. So you can kind of see how it relates down here, okay? So when we have one of our parts and a whole, generally speaking, what we want to do is some subtraction to find the other part, right? Because, I mean, our whole minus our part is going to equal our other part, whereas when we take our parts and we add them together, it's going to equal our whole up there, okay? So we're trying to find A. So how I'm going to set this up is I'm going to go 747 minus 278 equals A. So I'm not sure what A is yet, right? Because I haven't actually done the subtraction. But here's the thing. A lot of times when we're doing stuff like this, we can't actually fit all of our work on the one paper. So what I do is I have another piece of paper just sitting nearby so that I can work things out, okay? So here's what I'm going to do. I'm going to move this up so we can still see what I'm doing, okay? And I'm going to set this up vertically like this, okay? Now you could try and squeeze it in right here. I like to work a little bit bigger, so I'm just going to do it this way, okay? So of course we've got to do some borrowing. So I'm going to go ahead and let you figure this out on your own real quick. But before you do, I'm going to say down here A equals blank. So really, to find A, we do this subtraction problem, and then once you find your answer, you would just fill it in here because that's what A is equal to, okay? So go ahead and pause and try and work this out, and we will work this out together in just a minute. Okay, so obviously we need to set this up. So we've got, well, we're gonna go ahead and go all the way across first, because that's, like I said, how I like to do it. So now all I have to do is go through and do my simple subtraction. So we've got 17 minus 8, which equals 9. 13 minus 7 equals 6. 6 minus 2 equals 4. So we take this and we put it in here because that's what we were looking for after all, right? So our answer is 469. All right. So I'm going to have you go ahead and try number 2 on your own. Now remember, we add these two together, we get our whole. We are looking for the whole in this case. So up here they have it set up a little bit differently, right? They have it set up as a subtraction problem, but really the easiest way to find what b equals is to add these together. So I'd like you to set it up the same. So you would literally just write this right here plus this equals b, and then b equals blank, and go ahead and work this one out. So I'm gonna go ahead and have you check this with a partner in class tomorrow. So I'm not going to work this out in the video for the sake of time, and we'll talk about this one tomorrow. This one is set up exactly the same as this one. So if you want to work this one out just to get some extra practice, awesome. That makes you a math nerd, which is great. Okay, now we have a tape diagram over here. So it looks a little bit different, but really it's not that different from our math mountains, and I'll show you why. So we have our big number up here and two numbers down here. We know what one of them is, and then this is our unknown, so we're solving to find e, right? So notice on our math mountains we have our big number at the top, just like right here. Then we have two numbers that are going to end up smaller down at the bottom, right? Because those are our parts. It's the exact same way right here. So we could act like we've got our little lines like that if you want, or you could even rewrite it as a math mountain if that would help you. And so it would just look like this, right? And so this one is actually technically related to one of these already. It's just it just looks different because they use a tape diagram instead. So remember, if we have one part and the whole, we subtract to find the other part. Okay, so this would literally look like this, equals e, because e is our unknown, right? And so instead of a number, we're just gonna put e for right now, and then down here we say e equals blank. So I'd like you to go ahead and solve for e, and once again we will discuss this in class, but do recognize that these numbers should look a little bit familiar because we used them in one of our other problems over here. So if you really need the help, we kind of already worked it out in a way. All right, so kind of moving on to down here, we've got some word problems, and really this is all about identifying relationships between numbers, okay? And so that'll help us, because it'll help us determine what we need to do in our word problems. So let's go ahead and take a look right here. So of 800,000 species of insects, about 560,000 undergo complete metamorphosis. How many species do not undergo complete metamorphosis? Okay, so we're going to go back in here and we're going to circle our numbers, box our question, because that's what we always do, right? So we have a really big number, a slightly smaller number, and then these 560,000 undergo complete metamorphosis. So I'm going to go ahead and underline that. I might use my pen just so you can see it a little bit better. Okay. So we have this, and we have two numbers. And if we have two numbers, we can make our math mountain, right? So, of 800,000 species of insects. Now, that's a really big number, and we know that that's going to be our whole, or our total, right? Because it's big, and it says of 800,000. So that's kind of like saying this is all we have, right? So I'm going to come over here and I'm going to set up a real quick math mountain. So we've got 800,000. Now if we have the total or the whole, that means this has to be a part, because we can't have two wholes, right? So we've got our whole. We're going to put one of our parts down here, which means we are solving for this. And just for the sake of ease, I'm just going to call this A for answer, all right? Now really, what this is equal to is the species that do not undergo complete metamorphosis. Okay. And so what we're going to do is work this out, okay? So we know that if we have a whole in one part, we subtract to find the other part, okay? So if we were to set this up as a subtraction problem, it would simply be 800,000 minus 560,000. Now, once again, we don't have as much room as I would really like to be able to work this out. So what we're going to do is set this up on here. So let's see. So this was for number 1, and this is for number 5. So I'm going to set this up. That's 560,000, and I'm going to give you a second to go ahead and try and work this out. So of course, with our zeros, we can go all the way over to the 10,000s spot, and then we have to start breaking things down. And so pretty straightforward as far as what we're doing. So all I did was I took apart one of my 100,000s and moved those over into my 10,000s so that I could subtract properly. So remember, when I take away one of my 100,000s, I just move all 10 of those 10,000s that it took to make the 100,000 over into here, so it ends up as 10 minus 6, and then I'm left with only 100,000 in the 100,000s place. Basically what this comes out to is A equals 240,000, right? Now you don't have to use A for answer. You could use N for number, or really any letter. It doesn't really matter that much, as long as you know how to work it out properly. All right. So I'd like you to go ahead and try number 6 on your own. I want you to think about the relationship between these two numbers, okay? So I guess I'm gonna help you out just a little bit. So the Great Pyramid of Giza has about 2 million stone blocks. A replica has 1,900,000 fewer blocks. How many blocks are in the replica? Okay. So I want you to think about your math mountain, okay? So we have, our whole and a part and another part. So I want you to think about what here would be a whole and why. What here might be a part and why. So a whole is generally going to be the largest number that you see, and especially when we see something like fewer blocks, generally speaking, we know that we have at least one part. So I want you to think about what should you do if you have these two numbers and why. So I'm going to give you a second to go ahead and try this one on your own. So pause and we'll work this out. All right. So when we're looking at this, of course we want to start by circling our numbers and boxing our question so we know exactly what we're looking for. Actually, I'm going to pause for just a second because I didn't answer this properly, did I? So we didn't ever do our write for this. So we did the read and the draw, but we didn't do the write. So we can say about 140,000 species. So proof that even teachers make mistakes sometimes. It is okay as long as we learn from them. So we're gonna learn from that and do this one properly, all right? So we have 2 million stone blocks, and the replica has 1,900,000 fewer. Okay. And so this is the biggest number, and we know that that's kind of our whole because it says that it has this many blocks, and then how many fewer blocks does the replica have. So I'm going to go ahead and set this up as the 2 million up here, and I'll set this over here as the 1,900,000, which means I'm looking for this, and in this case I'm going to go ahead and use N for number. Okay. So let's go ahead and set up our problem over here. So it's going to be very similar to what we've already done, right? So 2 million minus 1,900,000 equals N. N equals blank. So how many blocks are in the replica? So I'm going to set this up as the replica has blank blocks. So set it up a little bit better than what I did on the other one. Okay, so there we go, we can still see. All right, so once again, I'm going to use my little paper down here. Some people call this a homework helper page. It's just something that you should probably start using if you haven't started already. and it'll just help you out. So we're going to go ahead and set this problem up vertically so that we can go ahead and crush it. All right. So we've got our bunch of zeros, right? So we can go all the way over to the 100,000s, and then line that up very well. Okay. So we're gonna go all the way over to the 100,000s, and then start unbundling things. Okay. So I have to take apart one of my millions, so I only have one left, and I'm moving. excuse me. My 100,000s that I just made by unbundling over to here. And so I've got 10 minus 9, which equals 1, and 1 minus 1, which equals 0, which means that this is my answer. Okay, so we take our answer and we just plug it into what we've already made. So we've got our 100,000. The replica has 100,000 blocks. Okay. I'd like you to go ahead and try this one, but I want you to think about this for a second, okay? Last year, 439,508 people visited Funtown. So Funtown is some sort of amusement park, right? This is 46,739 fewer visitors than this year. So this is how many people went last year, and it's this much less than this year. So we're looking for this year, right? So how many people visited Funtown this year? So once again, we want to set this up as our little math mountain because that helps us understand what we're trying to do. And so really what you want to think about is one of these a part and a whole, or are they both parts? Okay, so we'll I'll star this one so that we can discuss it in class. So once again, you're probably going to need your homework helper. So why don't you go ahead and try number 9, and I want you to think about why this is a part and a whole or a part and a part. Okay, so we're looking for how many visited this year, but we don't have a number for this year yet. So think about that and why it might be one or the other.